you go.
Awesome. That's maybe not a good thing to start off with in terms of longest title, but I assure you that each one of the Ks, there might only be one, stands for quality. So let's go ahead to the next slide. Yeah, so I'm Holden. My pronouns are she or her. It's tattooed on my wrist in case I forget in the mornings. I got a little fucked up when I got hit by a car, though, so 0 out of 5 stars. I don't recommend it. Oh, also, my team is hiring. So if you are interested in renting your soul to a giant megacorp, please come and find me in the hallway. I am not that hard to find. And if you find another person wearing a sparkly dress, I'm sure their team is also probably hiring. Yeah, let's go ahead to the next slide. Yeah, also not super related, but I think for those of us who are building data or ML tools, it's really important that we try and create inclusive communities so that we don't accidentally just recreate yesterday's biases with more software. Yay! And so, this is sort of who I am outside of tech. I'm Canadian. I actually got my green card this year or last year. I'm a little fuzzy on that. Prior to that, I was on an H-1B visa. 0 out of 5 stars. Once again, do not recommend either. But yeah, I'm super stoked that I get to live here. Next slide. Cool. And so I have a bunch of probably relevant biases that we should keep in mind. I tend to work with really large scale data sets. So when I talk about data processing, I tend to think about things that really don't fit on a few hundred computers. To me, that's the small scale data. And that's just because the people who pay me money tend to have lots of data. I've also worked on some of the tools that I'm going to be talking about. Those are the tools that I know better. Some would say that makes me biased to think those tools are good. I think that makes me biased to think those tools are crap because I know how they work. And so sort of just keep that in mind as I'm talking. Oh yeah, I also really like strongly typed systems, which does give me some bias against Python. I'm sorry for Python folks. But yeah, cool. Next slide. Oh yeah, and I really love my dog. So he's in as many of the slides as I could fit him on. Cool. So we've got a bunch of different characters for today. We've got Hadoop MapReduce. That's more the OG kicking it. We got Apache Spark. All kinds of fun. If you've ever said to yourself, damn, I don't have enough out of memory exceptions, Spark is here to help. Then we've got sort of two of the new kids, Dask and Ray. And if you've ever said to yourself, you know what, I really wish there was a pandas distributed data frame, that's Dask. Only people I know have actually sort of gotten anywhere close to that. And the Ray folks, if you ever were like, you know what, I really wish more of Python was written in C instead of Fortran. Yeah, cool. The Ray folks are pretty rad. And then Flink, also JVM, more streaming than Spark, not as familiar with it, but they did a lot of things better with their Kube migration than Spark did, and we'll sort of talk about that. Part of that is they didn't cheat as heavily as we did when they were on top of YARN. So next slide. Rockin'. Yeah. So there's a bunch of different challenges that we're going to face in our migration. The biggest one that sort of everyone here is used to dealing with is our good friend state. The next one is scaling up and down. The state one, though, is the one that's really painful. Thankfully, scaling up and down is something that everyone sort of has to deal with. Another one is sort of the debugging experience, which is something that I think we can forget about as platform builders because we're sort of focused on making the thing work. But it turns out that nothing ever really works. So we really need to make sure that people can figure out what the hell is going on. And yeah, we kind of screwed the pooch on that one in some ways. But looking at it another way, just all of these systems were sort of created before data on Kubernetes was really a thing. And so it's all sort of a port experience. And so if you've ever played video games from the first Xbox on a more recent Xbox or PS1 on PS2, you know that these ports are not perfect. They're pretty good, right? But we've definitely got some rough spots and we're working on them. So yeah, and that's my dog again. He's cute. Next slide. Cool. So why do we have to care about state, right? Like this data processing stuff, like surely I can just write all kinds of stateless transformations, like that's what Spark does. Why is the state thing mattering to me? Why am I having to deal with that? Well, so it turns out that like to power a bunch of stateless transformations, we actually end up using a bunch of state underneath the hood. It's kind of crappy, but it's what comes, yeah. That's what comes to it. Also, if we start dealing with streaming data, then we have to start keeping track of what data we've processed and what data we haven't processed. All kinds of fun. Aggregations, all of these things. The TLDR is I need to know if my dog has had a bath this month, right? And so it turns out that no, Timbit has not had a bath this month because when I put him in the sink, he gets very, very upset. So next slide. Cool. So what are some different ways that we can achieve fault tolerance, right? So a big part of all of these data processing tools is fault tolerance. And that's essentially computers are terrible, they were a mistake, but unfortunately, we're stuck with them now. So we have to deal with the fact that they're going to fail. And there's sort of these broad different techniques. The top one is sort of the one that MapReduce picked. It's kind of a cop-out, which is just like, we're going to say that my storage is reliable. I'll just put it in this reliable storage. And then the fact that my computers are garbage doesn't matter. And that's great, except for the fact that someone has to make this reliable storage and then it has to like work. And that part kind of has some opportunities for growth, as it would say in a performance review, and could perhaps achieve better performance, as it might say in a performance review. Recomputing on failure, this is the sort of Spark and Flink approach, and to a lesser degree Dask approach. And essentially that's like very much just, failures aren't that common. If things go wrong, we'll just sort of redo the work that we did before. It'll be great. This kind of sort of works, except for when we get correlated failures. And it turns out that the kinds of failures we get tend to be correlated because spot instance pricing can cause correlated failures. Machine failures cause correlated failures, et cetera, et cetera. So really, really great, except for the like whole in practice thing where things kind of go sideways. The other option is we just throw some extra computers at it and some fancy math on top of it. That is the approach to a certain degree taken by Ray, although honestly, Ray mostly takes the approach of ignore it. Pretend my computers work and everything will be just fine. And if that works for you, that's really great. In practice, that's an exciting opportunity to rerun your pipeline repeatedly. So Ray, by default, just assumes the computers totally work. And yeah, that doesn't work. But that's okay. Whatever. They'll fix it, I'm sure. Next slide. Right. And so here we just see all of the things that I talked about. So if you forget what I said before, you can go look at these slides later. Okay, so, and once again, also the puppy. He's taking a nap. Yeah, there he is. Okay, next slide. Oh, yeah. Okay, cool. So let's talk about how Spark cheated on YARN. So Spark on YARN is sort of like the traditional de facto place that Spark has been historically deployed, and we just cheated the heck out of it. So essentially, we had terminate and stay resident, which is like not really a thing on Kubernetes, right? Like when our pod goes away, they don't just let us like leave a few extra processes hanging around, right? Like you're gone. Whereas on YARN, we were just like, hey, so just like when my executor goes, it's okay. Just this is their good friend. You can totally trust them with the files. No security problems here. Just if anyone shows up and asks for a file, just give it to them. No problem, no problem. And that's what we called the shuffle service. Totally great, really lovely. Didn't work when the node itself actually failed, but worked really well when we sort of had executors coming and going, which it turns out that that's most of what we have. The underlying nodes themselves are relatively reliable, but the executors themselves, those out-of-memory exceptions that we were talking about, all kinds of fun, right? And so this let us cheat, and we sort of were able to pretend that our code was more reliable than it actually was. And then when we came to Kubernetes, and I started asking people like, hey, how do I like leave a program around after my pod is gone? Everyone was just like, no, you don't get to do that. And I was like, oh crap. So yeah, we don't get to do that anymore. Okay, next slide. Yeah, okay. So we don't get to do this like fun hack that we did on Yarn. So what do we want to do instead? So ideally, right, we want this fast write where I'm like writing to a local disk and I can terminate and still serve files from that local disk magically. We don't get that, not available. Fast read and write from one movable place, right? So maybe I've got some kind of magical volume. I can remap it to different pods. You know, that would be pretty cool. Ooh, I misspelled fast. The Y is a T and the K stands for quality. So fast read from many places. Read from many, write from one. Not really sort of a thing in Kubernetes so much. Read and write from many places. Okay, we've got that. There's some performance downsides. We'll talk about that soon. And fundamentally, this all comes down to that state problem we were talking about before. Next slide. And so yeah, on Yarn, we sort of got this. We got this by cheating and being bad people. That's okay. My dog is cute. Oh, wait, no, that's a picture of some yarn. Never mind. Next slide. Okay, is this my dog? I can't see so well. Whatever, we'll assume this is a picture of my dog and he's cute. So do we get what we want when we're running in the cloud? Ooh. The answer is, so we don't get to terminate and stay resident in the cloud, right? Like Amazon does not let you leave a running process on someone else's, AWS instance. They're like, no, that's not how that works. But we do get the ability to sort of remap our volumes and move them around. Those EBS volumes, we can move them around. It's pretty cool. Things like OpenStack, we can do similar things, all kinds of fun. This whole read from many, write from one, not so much in the APIs. On the other hand, read from and write from many places, totally, yeah, we can do that. The downside is the performance / the read after write, one of those two, sort of starts to become kind of sad. And it turns out that we kind of want to read the data right after we've written it. Who would have thought you would want to read data after you wrote it? Crazy. Next slide. So what do we get on Kubernetes? And no, see next, and essentially expensive. And so the TLDR is when we come over to the Kubernetes world, our storage story becomes all kinds of fun, also known as an exciting opportunity for consultants to sell you things, or Dell, EMC, whatever. Insert vendor here will totally solve this problem for money. It turns out, though, that I'm lazy and cheap, so I don't really like that. So next slide. Okay, how do we work around not getting what we want? So just like Professor Timbit here, my dog, he does not particularly enjoy being on this floating raft in the middle of the Ottawa River, but for enough treats, he will be on the floating raft in the middle of the river. And just like in Spark, for enough resources, yeah, it doesn't particularly like running on Kubernetes, but we can just make it work. Same thing with Dask and Ray. So one option is we can duplicate our state. Dask doesn't really have this concept so well. Flink and Spark do a lot better. Ray really does not have this concept at all. It's unfortunate because I really like Ray, but that's okay. The other one is we can just try and move our state quickly. So if we hear like sort of from Kubernetes like, hey, you're going to get moved to another computer or I'm going to kill you, then we just go ahead and copy out the most important things that we think to another pod really quickly. And the last one is this lazy write through to persistent storage. So sort of give up on trying to write everything to persistent storage all the time, but try and write through lazily. This is somewhat useful. This is the approach taken in Spark for medium-sized files if you have it turned on. And it kind of works, sort of. Next slide. Okay, yeah. So if you're the kind of person who is like, that sounds cool, I want to go see the code, I encourage you to go take a look at this very exciting Jira ticket, Spark 20624, which will link you to a collection of exciting, wonderful pull requests. And you can see this code. It is garbage. But I wrote it, so I'm allowed to say that about it. So terrible code. Most of it lives inside of this thing called block manager decommissioner. And that is where we just try and copy state around as quickly as we heckin' can before we get killed. Next slide. Yeah, that's what the Jolt Cola was for. Okay. So that's great. We've been talking about state, but it turns out that there's more than just state, although don't have a super amount of time. The other thing that we care about is figuring out how do we get these pods? How do we get the right number of executors? How do we get the right type of executors? And the first sort of attempt at doing this in all of these approaches was just like, that's fine. I'll just directly create a whole bunch of pods. So I'll just issue 1,000 API requests, and they'll just issue another 1,000 API requests, and so on and so on. And it turns out that that is what we call slow and not good. So next slide. Instead, we do some different things. So what happens in Ray today is it runs kubectl exec underneath the hood. Oh dear God. I don't know why. Dask uses the pods API. Thousands of API requests, whatever. At least it's not running kubectl exec. I can live with it. Spark, big shout out to the Apache Unicorn and Volcano folks who actually wrote this code because I am far too lazy. Yeah, big shout out. Wait, did you write that code or are you just joining the shout out? Okay, just throw. Okay, cool. Because I'd buy you a Bud Light Lime if you wrote that code. Okay. So good news is Unicorn and Volcano, they actually wrote really cool things and Spark is able to plug into them. And not only that, they wrote the plugins. Flink, sort of longer story here. Once again, if you want to go and see that long story, Flink 26559 has a whole bunch of people being really sad. But you can sort of kind of make it work if you use a separate operator. Okay, next slide. Yeah, mixed priorities, dynamic priorities. Yeah, we totally get mixed priorities. That's great. This whole expressing my priorities changing over time for pods, not great. So we have this idea that like state can come and go, and some things might temporarily be more important to me, and I don't have a really easy way to express that. To be clear, I don't have a really easy way to express that on YARN either. On YARN, it didn't matter though, because I got to cheat and I could just leave my state there for later. Next slide. Oh, right, upgrades. Yeah. We've got 1 minute. It's cool. Next slide. Oh yeah, UIs. Those are totally important. We don't get those. We get to do kubectl port forwards, except Dask and Ray actually did a really nice thing here where if you're deploying with their Jupyter Notebook plugins, they do a whole bunch of magic underneath the hood to do a whole bunch of port forwarding, and you actually get to see the UIs. It's really nice. It's really lovely. We should do that in Spark, but we haven't yet. Next slide. Okay, cool. And right on time. We're done. My team is hiring. You should follow me on the internet. And if you have any questions, once again, come find me. I'm going to go get coffee that doesn't taste terrible, but I will be back this afternoon with better coffee. But that coffee's mine. You got to get your own coffee.
Do we have, I'm sure we have questions. We can take one question. Who wants to ask it? Okay, we got someone all the way in the back.
In the meantime, I'm excited to tell you, oh, sorry, I've been trying to reach you about your car's extended warranty. It is about to expire. Do you have questions about your car's extended warranty?
I'm not sure. I'd have to check.
Or Spark on Kubernetes.
But question about the block decommissioner. Is the purpose of that just for terminating state when your pods are shut down, or do you do that more routinely?
So we all know that data is the most vital asset that.
Whoa, that's not me. Okay, yeah. So great question. Right now, we only use the block decommissioner when we are being informed that we are going to decommission, or if Spark is initiating a scale down event. We don't proactively move state with it. It's only reactive. There is options to proactively duplicate state, but that's a different mechanism.
Cool. Thanks, Holden.
Yay! And once again, come find me for your car's extended warranty, timeshare needs, or to talk about data on Kubernetes.
Or Bud Light Lime.
Oh, yeah. If anyone really loves Bud Light Lime, that is my jam. I drink shitty beer all the time.